As Kate noted, our first attempt to launch this flight test last Thursday ended early in a pad abort. Let's dig into that a little bit. So 4 of Super Heavy's 33 Raptor engines aborted at startup due to issues with their aux turbo pumps. Those rapidly pressurize and feed liquid oxygen into the engine for combustion. For those of you that like to pay real close attention to the on-screen telemetry, you saw this at T0 during that first attempt. We command the engines to start up simultaneously. You get some slight differences as the engine adapts in real time, but you saw 4 not light up. So 4 out of 33, what exactly happened? We have a launch constraint built in where we can only be down 2 Raptor engines at liftoff. So the vehicle detected more than that, we're out, automatically aborted before the final T0 safely shut down all of the engines that started up. We dug through the data, and what we saw was some off-nominal spin response in the aux turbo pumps on 6 of the engines. So the most likely root cause was determined we were collecting some moisture inside of the pumps from previous operations, which then froze when we introduced that cryogenic propellant, and that either slowed those pumps down or stopped them completely from spinning. So for this next flight attempt, we swapped in 6 engines that were already at Starbase, and we did a test back on Wednesday that allowed us to check out the newly installed engines and spin the aux pumps on all 33 after they were chilled, check out their performance before we got into another launch attempt. We pulled a bunch of those engines off, as we said. We tested one on a test stand up at McGregor, helped screen for any other issues that might be hiding, and that one was actually able to do a full booster ascent burn. So got us in a good position for today. Even though we didn't get off the pad last week, we learned about the engines, the prop systems, how they perform in the flight environment. Already going to drive some changes to make Starship more reliable. We also got a real-world test of an abort that's designed to take place at one of the most critical dynamic phases of flight. We safely shut down 29 running Raptor engines, safeguarded the vehicle and the pad. A mountain of work goes into designing aborts. You've got software, hardware engineers just dreaming up bad day scenarios, how we want the vehicle to respond, just to give us the best possible path to maximize safety, preserve the mission and the hardware, so we're able to do that.
-9, 8, 7, 6, 5, 4, 3, 2, 1.
Vehicle is pitching downrange. Booster Raptor chamber pressure is nominal.
When we're only a week out from flight, my main focus is getting into flight. The thing that separates us from a lot of other companies is that we test fast and we test often, and that includes launches. We want to make sure the vehicle's all ready to go, we want to make sure the ground's all ready to go, but we also don't want to be caught in analysis paralysis.
Our main objective today is a 10-engine static fighter. Aboard. On LVN1, looks like we kicked out due to 2 combustors from the apex being pelted.
There was a pad side abort called.
These things were holding like 5,000–6,000 tons of propellant plus the rocket weight, and it's like, okay, well, why didn't you guys simulate that? It's like, well, because we didn't have anything that weighed that much. Like, this is the first time we put anything on it that weighed that much. So there's just so much that you have to think about and be very paranoid on.
We kicked out early. All teams triage alerts, prepare for offload.
We actually had another pad abort on the diverter.
Basically, right during engine firing, it was so much noise and vibration that it actually shook the sensors that are located out in this area enough that they aborted us out of the test. We went back, obviously, afterwards and looked at all the data and tried to come up with smarter ways to basically still protect the integrity of the diverter throughout the operation while changing our parameters so that we were making sure that we would not abort again. A flame diverter is like a super simple concept that is like not at all complicated in operation and is just absolutely murderous in the details. These are extremely sophisticated thermal load sensing devices. If they turn into melted metal slag, then you know that you got too much heat. If you melt this, you're hotter than aluminum melts. If you melt this, you're hotter than zinc melts. If you melt this, you're hotter than copper melts. If you melt this, you're hotter than Sharpie melts. So we're sub-Sharpie. We have all of this mass flow, all of this energy that is just absolutely trying to obliterate our pad. We want to give it a thing to obliterate, to keep from obliterating the things that we care about. And the thing we give it is water. The amount of energy that water can absorb is like miraculous. And so if you can get high enough pressure water in the right places and just allow it to flash boil that water, then it solves a lot of the problems for you. Like the idea is that the steel never gets that hot, the structures never get that hot, because the water absorbs all that energy, turns to steam, and everything's okay.
So for this flame deflector on pad 2, we're sitting somewhere in the neighborhood of about 650,000 gallons per minute. That's approximately in the range of about like one entire Olympic swimming pool being drained in the course of a minute.
You're trying to look into this thing and you see how glowing hot it is. It's just, yeah, a pretty impossible environment to keep something happy in. But, and you zoom in and the flame deflector's still there, so that's the reason we build those things.
Putting the rocket into human terms is something really tough. 65,000 pounds per second of propellant that is coming out of the engines. And again, just like 18 million pounds of thrust, like what does that number mean? I think of like 11 Ford F-150 trucks per second just zipping out of the bottom of the rocket. It's like imagine if you had the world's biggest machine gun, except for instead of shooting bullets, it was shooting pickup trucks, and it's just firing 11 pickup trucks per second out of the bottom of the rocket. It's like, do you think your stuff could survive that?
All but 5 engines down.
Cut off. Tap.
6 ignite.
Backburn startup.
And the booster now doing its boost back burn. It looks like we lit all 33 initially. Now we're down to 13. We're seeing 6 out of 6 Raptors lit on the ship.
Backburn shut down.
Awesome shot, you can see it there. So right now the booster is using their 3 hypersonic grid fins to guide itself through the atmosphere toward its landing site. You can see we're only 5 kilometers above the sea right here.
Backburn startup.
Just heard the call out for landing burn startup for the booster. I have a feeling the crowd's about to go wild here. Yeah, we sure did.
That was awesome. From the booster splashdown. And engine shutdown. All right, Starship 6 Raptor engines have successfully shut down.
Nominal orbit insertion.
And there's our call out for nominal orbit insertion. Yep, looks like we've just got those last 2 to go. These ones might be coming out. Oops, they're starting to see motion. $19 out the door, one more.
It looks like we got a crowd at our Hawthorne, California location. Some colleagues gathering outside of mission control there as well.
That marks, if I'm not mistaken, our 20th. So our payload deploy sequence is now.
Starship is starting entry. Good attitude for entry.
But this is going to be a pretty critical test for what we'll eventually need to do when we do orbital missions. When you got to relight those engines, do a burn to get yourself out of orbit. One thing that is unique on this one is we're going to be lighting it for a little bit longer of a time. We're expecting this burn to be up to about 14 seconds. We've only done about 3 seconds previously. And so that should be coming up within the next couple of seconds. Let's stand by.
Relight demo startup.
You see relight there on your screen.
Wow.
And confirmation over the net. Relight shutdown. The burn has ended. Congrats to the team on this milestone.
Starship is executing the swoosh maneuver.
As we get it. We didn't do any real stress tests or anything on this flight. We did do, you heard our landing Large flight controller call out. We were doing the swoosh maneuver. This is kind of the final maneuver that we plan to have starships returning to Starbase do, that will essentially hook them out over the Gulf before coming in and over Tower 2. But about 10 seconds away, look for 3 Raptors, the 3 in the middle, to light up, do a flip. Let's see if we can get this thing in the water. 3 sea levels lit. Seeing healthy chamber pressures on. Did our flip down to 2. Starship descending into the Indian Ocean, down to 1. And we're in the water. And it's a soft splashdown in the water. That is a first. That is the softest splashdown we have ever had with the Starship. There